Hi, and welcome to our presentation for the paper Towards Codeswitch Classification Exploring Constituent Language Resources that has been accepted in AACL IJC NLP 2020 Student Research Workshop. I am Karthikeya Pant and my co-author is Tanvi Tadu. I am from IIIT Hyderabad and she's from NSIT New Delhi, and both of us have had equal contribution for this paper. Code switching is the juxtaposition of speech belonging to two different grammatical systems or subsystems within the same speech exchange. In other words, we can say that it essentially denotes a shift from one language to another within the same utterance, but it's important to note that it's not merely the insertion of borrowed words, fillers, and phrases. It often involves morphological and grammatical mixing. And as has been observed in previous studies, it's a common phenomena in the multilingual communities, especially when people who are speaking both the languages have similar frequencies in them. And we can see code switching among languages like Spanish English, Hindi English, Tamil English, since both of them have a large number of bilingual speakers of similar fluencies. And since it's often founded, so basically, to be honest, like it's critical for enhancing user experience in various industrial settings, and hence it becomes necessary to study it. Now, there are some challenges which are there when we process code switching or code switch data. Firstly, there is a limited availability of data, and not much work has been done on code switched language or code switched setting. And another thing is that it's likely to be found in informal settings like speech, social media, and semi-formal settings such as navigation instructions, which leads us to acknowledge code switching as a legitimate communication form, which has a specific purpose, and it deserves careful linguistic analysis and processing. Thirdly, like most works have been limited to language independent methodologies, and hence it becomes important to exploit the features that are specifically for certain settings. So our contribution in this paper is we proposed a generic approach of converting code switch data into its constituent high resource languages. We also proved that it's effective for both monolingual and cross-lingual settings, and we also enabled the exploitation of pre-trained transformer-based embeddings such as BERT and Roberta, BERT-based settings such as Roberta and ULM-FIT, which is another pre-trained setting. We will be coming back more on that. We propose, we benchmark both these approaches for hate speech detection, sarcasm detection using the current state of the art, and language independent supervision learning. So as the baseline, we observe an increase in predictive performance. So we enable multiple forms of approaches. Firstly, we transliterate and convert this low resource task into a high resource one using cross-lingual learning, because we will be coming up more on that. We have an architectural diagram which explains a lot of things. But apart from that, we also translate, which utilizes monolingual resources of each of the constituent languages. And on a different note, for classification, we have used the following models: ULM-FIT, Roberta, XLM Roberta in our approaches. So now coming back to the main approach. For example, we have this sentence: "Abhi Bhopal tumhare dimag mein politics घूम रही है, shame on you." So this is a code switched utterance which is made up of English and Hindi amalgamation. So firstly, we just identify the individual tokens which are there for their constituent language, and as we can see, we have Apart from 4 words, all of the words were in Hindi. So, and shame on you follows grammatical syntax of English, further confusing the model to do anything. So, firstly, we have 3 approaches. For the first approach, we convert it into Hindi. So how do we do it? Like we transliterate the Roman text into the Hindi one, and then we run a ULM fit classifier on it. Secondly, we convert it into English. So we transliterate all the words we took. For example, you can say that we use the Hindi database, and then we translate it into English using Microsoft's NMT. And then we run a Roberta classifier over it, which, so for example, it quite fairly resembles the correct meaning. Now, Bhopal is the only politics circulating in your mind. It's quite similar to what we actually mean. And thirdly, so coming back to the third approach, we convert it into code mixed. So what we do, we retain the correct script for each token. So for example, Abhi Bhopal Tumhare Dimag mein, we just convert it into Devanagari, which is the script for Hindi. We leave politics in the Roman script, and we also convert He Ghum Rahi Hai into Devanagari and leave Shame on You, which is in the Roman script because it's in English. So we do this, and we benchmark this approach for 2 downstream tasks of sarcasm detection and hate speech detection for the English Hindi code switch pair. And our results show that the XLM Roberta, which means the cross-lingual approach, which was the third one in the last slide, it outperforms all the other approaches. For example, you can see via F1 that we achieve a very high, much higher performance, which is quantitatively it's 22% more than CNN. And on the other hand, we can see that again the XLMR approach, which means the cross-lingual approach, outperforms all the other models, even our other approaches and all the baselines, and quantitatively it outperforms the baseline by a margin of 42.5%. So we can conclude that we convert code switch data into its constituent languages and then enhance the predictive performance. We have already quantified improvements in the previous slides.